Okay, today we're going to talk about dividing fractions and mixed numbers. By the end of this lesson, you should be able to say, I can divide two fractions. Let's begin by looking at some models that involve division with fractions. Now, we did this in class, so this shouldn't be new to you. Let's start off with whole numbers. How many 3's fit into 12? Well, if I have a bar that is 12 inches long and another bar that's 3 inches long, I can put it in 1, 2, 3, 4 times. So asking how many 3's fit into 12 is really the same as asking what is 12 divided by 3, which we all know is 4. Let's look at another. How many 5's fit into 15? Well, I can take a 5 and put it into 15 3 times. So if I'm asking how many 5's fit into 15, it's the same thing as asking what is 15 divided by 5. Now let's think about dividing with fractions in the same way, as a fraction fitting into a whole number. How many halves fit into 2? Remember, this is the same thing as saying, what is 2 divided by 1/2? So let's put it in. How many 1/2 inches fit into 2 inches? And the answer is 4. So I can say 2 divided by 1/2 equals 4. You might be thinking, this doesn't make sense because the quotient is bigger, and I'm not used to seeing a bigger quotient, but it does make sense because remember we're working with fractions. And fractions are the same as decimals. And we noticed in the last unit that things tended to work backwards when we were working with decimals. It's the same way with fractions. Let's make some observations. If I wanted to take the number 6, for example, and divide 6 by 2, I get 3. Let's look at a multiplication problem involving 6 that will give me a product of 3. If I take 6 and multiply it by 1/2, because I'm taking half of 6, and we said that word of means to multiply, I would get, if I simplify, 2 goes into 2 once, 2 goes into 6 3 times. Remember that 6 has a 1 in the denominator because all whole numbers are really a fraction with 1 in the denominator. And if I multiply across, 3 times 1 is 3, over 1 times 1 is 1. And I don't really need that 1 in the denominator, so I know 3 divided by 1, or 3 over 1, is actually equal to 3. Notice when I divided by 2, it was the same thing as multiplying by 1/2. Let's see if that helps us when we're dividing fractions. Looking at another example, how many 2/3 fit in 6? This is the same as saying, what is 6 divided by 2/3? So I take 6-inch strip and I see how many 2/3 of an inch fits into 6. And I can see that that's 9. So 6 divided by 2/3 is equal to 9. Let's look at dividing a fraction by a fraction. How many 1/4 fit into 1/2? It's the same as saying, what is 1/2 divided by 1/4? So if I took a strip of paper that was 1/2 inch long and took a couple strips of 1/4 inch long paper, I could see how many times that fits into 1/2. And I notice that happens 2 times. Remember that things are backwards or opposite when we're working with fractions. So dividing 1/4 is the same as multiplying by 4. So 1/2 divided by 1/4 gives me the same answer as 1/2 times 4. Both equations equal 2. That's interesting. As we go through this, see if you can make a couple more observations about these problems and possibly form a general statement about them. How many 1/16 fit into 1/4? It's the same as asking, what is 1/4 divided by 1/16? I could take a 1/4 inch strip and a couple of 1/16 inch strips and see how many times it fits in. And I see that it fits in 4 times. So 1/4 divided by 1/16 is the same thing I would get if I took 1/4 times 16. Let's look at that. 1/4 times 16 over 1. 4 goes into 4 once. 4 goes into 16 4 times, which gives me 4 over 1, which equals 4. Both equations, division and multiplication, in this case, give me an answer that equals 4. Sometimes things don't fit together just right. So for example, how many times or how many 1/3 fit into 1/2? It's the same as saying, what is 1/2 divided by 1/3? So I take a 1/2 strip and a couple of 1/3 strips and I put them and see how many times they fit. 1/3 can go in once, but when I try to do it a second time, it doesn't seem to fit just right. Only half of it, the 1/3 strip, fits on the rest of my 1/2 area. So what this tells us is that our answer is going to be a mixed number, because 1/3 can fit in one full time and then a fraction of a second time. How much? A half. Only a half of another third can fit into 1/2. So this tells us that 1/2 divided by 1/3 is the same as 1/2 times 3. Both equations equal 3 halves, or if I turn it into a mixed number, 1 and 1/2. Here's a hint. When I'm multiplying by a whole number, what's my denominator? It's a 1. Can I notice a relationship between my divisor in the first problem and one of my factors in the second? The key to division with fractions is remembering that you can simply multiply with the flip of the divisor, and we call that the reciprocal. So if I flip 2/3, or take the reciprocal of 2/3, I simply switch the numerator and denominator. So instead of 2/3, the reciprocal would be 3 halves. The reciprocal of 5 over 1 is 1/5, because I'm flipping the fraction, putting the numerator in the denominator and putting the denominator where the numerator originally went. If I want to find the reciprocal of a mixed number, I first have to turn that into an improper fraction. Because remember, division, we just saw, is a lot like multiplication with fractions. So when I'm multiplying by a mixed number, I still need to turn it into an improper fraction. So 3.5 is equal to 7 halves. The reciprocal of 7 halves is 2/7, because I simply flip my fraction. You can divide with fractions by remembering the following saying: keep it, change it, flip it. Keep it refers to what we do with the first fraction. We keep it. We don't do anything with it. Change it refers to what we do with our division symbol. We don't divide in a division problem when we are using the algorithm. I would change division to multiplication and simply flip the second fraction. So I would get 3/4 times 6/5. Keep it, change it, flip it. And that gives me 18/20, which I would then have to simplify to get 9/10. Let's look at another example. Remember the saying, keep it, change it, flip it. Keep it, I would keep 2/5. Change it, change division to multiplication. And flip it, flip the second fraction to 8/3. Then I multiply as I would multiply any two fractions in the world. And I get 16/15, which I would have to simplify, in this case, turn to a mixed number, 1 and 1/15. I can still keep it, change it, flip it when I have a whole number as a divisor. Because remember, a whole number written as a fraction is always the whole number over 1. So to keep it, I would keep 1/2 change the division to multiplication, and flip 5 over 1 to 1/5. And then multiply across. I get 1/10. If I wanted to keep it, change it, flip it with this problem, I would keep the 3/4, change the division to multiplication, but with my mixed number, I need to turn that into an improper fraction first. So 1 1/2 as an improper fraction is 3 over 2. Keep that in mind when you go to flip your fraction. After I convert to an improper fraction, I get 3/2, but then I need to flip it. 2/3. And then I can multiply straight across as I normally do, or simplify first. 6/12 is what I would get if I multiplied straight across, which simplifies to 1/2. Now it's your turn to practice. There are going to be 2 slides, each with 4 questions on them that you need to answer. On the first slide, you just need to rewrite the problem to change it from a division problem to a multiplication problem, keeping in mind that phrase, keep it, change it, flip it. In the second slide, you will actually work out the problem and do the division problem. Now, do these 4 problems in your notebooks. All you need to do is rewrite it as a division problem, rewrite each division problem as an equivalent multiplication problem. Pause the video now and do numbers 1 through 4 in your notebooks. When you are done, restart the video and continue on the next slide. On this slide, you need to actually find the quotient in simplest forms. Remember, you first need to keep it, change it, flip it, and then multiply just like any other multiplication problem. Pause the video now and do numbers 1 through 4 in your notebooks. Do not forget to WSQ in your notebooks as well.